This is Java program is a server application that can handle two types of operation: displaying real-time data using UDP and requesting log data using TCP. The main structure is the method run an infinity loop that prompt the user to choose between two operations, where this option 1 is start UDP server for real-time data display, and option 2 is requesting log data from IoT device using TCP. The user input determines which operation is performed. Start UDP server method. The purpose is to receive data packet from client over UDP, logs the data to a file, and display it in a real time. The datagram socket lines on port 9876 for incoming UDP packet. The received data is appended to a file named logdata.txt. A separate thread, display thread, continuously read and prints the content of logdata.txt every second, providing a real-time data display. And the server prints incoming data as soon as it receives the packet. The key features is use files read to append data to logdata.txt, creating it if it does not exist, handles potential I/O exception and interrupted exception gratefully. For requesting log from IoT method, the purpose is connecting to IoT device or other server to request and print log data over TCP. Details is a socket object connect to localhost on port 6786, send a request string requesting log data to initiate data transfer. Read and print the incoming log data line by line using a buffer reader. The key features is automatically close resource with the try with resource statement, displaying a error message if it failed to connect to the IoT device.
Greetings to Sir Adi. Today I am going to present about the IoT coding that we just did previously on problem-based task. So this program creates a basic server that waits for client connections and sends sensor data when requested. So import java.io and import java.net provide classes for input/output and networking, which are necessary for creating server-client communication in Java. Server socket listens on port 69,789 for incoming connections. When this line runs, the server is ready and waiting for client to connect. And client socket accepts is for pauses the program until a client connects. Once connected, it returns a socket object for interacting with that client. Buffer reader in reads data from the client's input stream, the data sent by the client. Screenwriter sends data to the client's output stream, data sent by the server, and lastly is in.readline reads a line of text from the client. The point is, this section sets up the communication streams between the server and client, and code for responding to the client's request. It is for checks if the client's request log data. If so, sends back a sensor reading identified Celsius response. The concept is a basic request response model. The client makes a specific request and the server responds with relevant data. And for error handling, which is catch IO exception E, system out println error handling client plus E point get message. So the reason is if there's a communication issue, an error is message printed. An error message is printed, sorry. So this makes the server more robust and helps us understand any problem during runtime. And lastly is starting the server and final error, which is catch IO exception E, system out println error handling starting server. The main reason for this is if there's an error when starting the server, an error message is printed. The concept is error handling in the main server setup phase ensures that issues are caught earlier. The main flow is server starts and waits for connections, second is accepts a client connection, that is reads client requests and checks if the request is for log data, and lastly is response with a sensor data message if requested. So the purpose is that a simple model of server client interaction demonstrating Java's networking capabilities in a small project. That's all for me.